Hola, ¿qué tal? Bienvenidos a una nueva edición de Conectados con Legrand. Mi nombre es María del Pilar Galeano y soy BDM en el grupo Legrand Chile. Realmente es un placer tenerlos nuevamente con nosotros en este Conectados con Legrand. De parte del equipo de Legrand Chile, quiero extenderles un saludo muy especial. Hemos recibido mensajes por interno, preguntas, y todo esto es lo que realmente hace que nuestro trabajo valga la pena, que es estar con ustedes y poder resolver temas que sean de su interés. Y bueno, para aquellos que quizás están iniciando con Conectados, les cuento que regularmente estamos con expertos del mundo de la infraestructura eléctrica en media baja tensión y también expertos del mundo de la infraestructura digital. El día de hoy tenemos un tema que está así en boom en el mundo de las telecomunicaciones. ¿Por qué? Porque hemos visto que en los últimos años ha habido una explosión de las comunicaciones, de equipos conectados a la web. Incluso se estima que este año terminemos en el mundo con 2.000 millones de dispositivos conectados a Internet. Y se habla que de aquí a 10 años haya 50.000 millones. Esto es todo un universo. Quizás 10 años atrás no nos imaginábamos que esto sucediera en nuestros mercados, pero es una realidad. Y bueno, obviamente dentro de todo este universo de hiperconectividad, hay unos usuarios que para nosotros son muy especiales, que son los usuarios IT. Hay usuarios IT en diferentes tipos de empresas, de corporaciones, en el gobierno, en entidades de salud, etcétera. Y todos ellos con diferentes niveles de criticidad en sus procesos. Estos usuarios han confiado su información a la nube, han confiado poder depositar toda su información, que es evidentemente invaluable, en los data centers de hiperescala, data centers regionales, data centers locales y data centers propios. Y bueno, debido a toda esta demanda y al hecho de que los usuarios cada vez se van haciendo mucho más expertos, también se van haciendo mucho más exigentes. Y esto hace que los data centers se vean en la necesidad de aumentar su coeficiente intelectual, para así también aumentar la continuidad, aumentar la eficiencia, la seguridad informática, brindar un mejor servicio a los usuarios. Y evidentemente esto implica que se debe tener una gestión más inteligente y más controlada de los data centers. Bueno, con toda esta introducción, les quiero contar que hoy para esto y en particular para esto está con nosotros Nicolas Sagnes. Nicolas es Product Manager de Legrand a nivel internacional. Él trabaja para la SBU de Distribution dentro del mundo digital. Él es Master Degree, también tiene más de 8 años específicamente en este mundo de los data centers. Antes había estado en otras unidades de negocio, dentro de los cuales ha estado en el mundo de los servicios y en el mundo de los productos. 5 de estos años los ha dedicado al mundo de los data centers en Estados Unidos. Entonces, él trae como una muy vasta experiencia de lo que son las exigencias de los data centers en Estados Unidos, y pues lo trae también a disposición para nuestros mercados, y ha sido de verdad un gran agrado para él estar trabajando estos años por toda su experiencia, por todo el conocimiento que trae y la manera en que también comparte esta información. Les cuento de manera general que este conversatorio se va a hacer en inglés, pero vamos a poner los subtítulos en español. Nos perdonan si no están tan en tiempo real, va a haber un pequeño atraso entre la voz de Nicolás y la mía y el texto en español, pero bueno, espero que nos tengan un poquito de paciencia con eso, pero es también para que sea amigable para toda la audiencia. Entonces, bueno, vamos a dar inicio, vamos a saludar a Nicolás. Hello, Nicola, how are you doing?
Hello. Thank you for having me, Maria.
Okay,
Doing great.
Thanks to you for sharing with us this time, this moment, for giving us or your knowledge, your experience, and of course your good attitude with all of this world of the telecommunications and distribution power, of course, into the data centers.
Sure, my pleasure.
Look, I was sharing with our audience the fact that in this universe of hyperconnectivity, there are companies of IT corporations, people in the government, health entities that are included into the data centers world, because they have trust their priceless information to the data centers. In hyperscale data centers, regionals, locals, and even their own data centers. And those users have increased their level of expertise. That means that the data centers must increase their IQ in order to increase continuity, efficiency, computer security, and providing a better service to their users. That also means having a more intelligent and controlled management of the data center. Am I right?
Absolutely. You're nailing it on the head. Absolutely. And we're seeing it as a vendor today. You're absolutely right to point that out. The intelligence inside facilities is more and more demanded and more needed to save money, save costs, and also guarantee availability for the critical applications of the business.
Okay, that's right. That's right. So maybe I would like to start asking you, in your opinion, according to your experience, which are the main challenges that data centers are facing today?
That's a good question. So we have different timelines to explain that. If we look at today, we are in the middle of that worldwide pandemic, COVID-19. And right now, the main issues are data centers customers face worldwide is provisioning. It's very hard to get products. As we know, a lot of factories, a lot of vendors worldwide stop their activity. And for data centers users that are deploying racks, deploying white space, it is increasingly difficult, if not impossible, to get their products and get the hardware that they need to support their plan of deployment. But that is just today. So leaving that on the side, if we look at what are the general challenges of data center operators worldwide, we can sum them up basically in two big categories. It's making sure that you convey availability to the business and reducing your cost. In these two categories, you have multiple ways of doing things. So if we take the case of availability, looking into challenges from an operator standpoint, it's going to be managing power capacity, making sure that you bring enough power into the rack, that you feed enough power to the IT equipment, and also that you avoid failover issues when you build your architecture, that your power is solidly implemented, so you can make sure that your IT equipment is going to run smoothly over the years. Another topic regarding power is disaggregation. Today, when we architecture data centers, standards are more and more detailed about how to design the infrastructure. So if an error occurs, or if an outside event comes into play, if I lose part of my infrastructure, I lose a small part and not a big part of my infrastructure. So I'm going to have to keep that in mind when I design my data center and when I operate it on a day-to-day using various tools and intelligence. I'm sure we'll discuss about that. If I look into the cost challenges, the main challenges of the operator is to keep the cost down and make the most of the IT equipment, deploy more equipment into the same rack footprint, and deploying equipment that consumes less energy. So a lot of KPIs exist today. PUE is the most well-known. More of them came into play with DCIE, reducing the mechanical loss as well as the equipment to avoid energy depredation across the facility from the entry point to the consumption point into the rack.
Okay, that's great. You are mentioning something very important, and that's the role of the wet room, of course, and the role of a PDU. and the importance of having everything controlled or at least measured. So in that point, why it is so important to measure with a PDU the electrical and environmental variables within the data center?
Yeah, and that's a question that a lot more users are asking themselves today. If you were asking that question 10 years ago, my colleagues would tell you that when they started implementing intelligent metering in the data center, nobody was doing it because the risk factor was very much lower than right now. The criticality of the application is so high today, and the cost of losing that application for the business, it's unbearable. So you have to have means of controlling the behavior of the infrastructure. So what does that mean? Intelligence at the facilities level, when the power goes through the facility, goes through the UPSs, the transformers, through the electrical power panel, all that needs to be in place and carefully architectured. But then when you go into the data center, into the white space where you have your equipment, why do you need to meter? Today, if you don't meter, and many users choose not to do so, you are basically flying blind. That means that if your equipment stops functioning, if you have any type of human error, somebody plugs a wrong plug into the wrong server, you can cause crashing failures and unwanted failures. And if you don't meter, you have no way of knowing what the infrastructure is doing. So that is true from a pure power standpoint, but also from an environmental standpoint. You mentioned, metering at the environmental level. The goal of that is to reduce the cooling footprint. How do you know if you're supplying too much air or not as much air as you should into the rack? If you're supplying too much air, you're basically throwing money out the window, and your air conditioning units are just burning cash. So you have to dimension them down while maintaining the level of availability. However, if you don't supply enough air, or I should say, if you don't remove enough hot air from your data center, we all know that data centers transform electricity into data, and the byproduct of that is heat. That heat is dangerous for the equipment. If too much heat accumulates in an area, you can cause failures of the equipment itself, and the life cycle is going to be shortened. So you have to remove that heat. In order to know where the hot air is positioned in the data center, you have to find ways to monitor and measure that through various means like sensors or heat maps, or just modelizing it through statistics.
Exactly. So we could say that a data center without metering is not an intelligent data center.
Absolutely. And an intelligent data center basically saves you money and also helps you manage it in the long run. That depends on the philosophy of the infrastructure and the applications that are running into it. It's all about deciding what level of risk as a user I am willing to accept. If it falls, do I need to remediate in 2 minutes, in 20 seconds, or can I allow myself to have 48 hours without my application? That determines the level of metering, intelligence, and then redundancy in the architecture that I'm going to design.
Exactly. Okay. You're speaking now about architecture, and one of the best practices that designers and operators use into a data center is the fact of having redundancy, right? For assuring continuity, for assuring the service, and all the point with the end user and with all the users of our end user. I mean, if the operator is paying for his information and for his services for some others end users, there's a chain of people which really need to have a good continuity. They really need to have efficient service with their critical processes and everything. So according to that, what role does a PDU play within the redundant architecture?
That's a great question. So what part of a PDU play in the architecture? It's multiple. So first of all, if we look at a data center architecture as a whole, today you have new legislation that kind of categorizes it. And we're looking into the European legislation, the EN 5600 for data center design. That is coming from the IEC legislation and classifies data centers by 4 main classes, depending on their redundancy, from class 1 with basically no redundancy to class 4 with a fully redundant active infrastructure at all levels. So first of all, when you design the data center, you're going to have to look at these different classes of redundancy at all levels of the data center: connectivity, power architecture, security, a lot of different areas to consider. In terms of power, when you look into the white space power architecture, the PDU is pretty much the last mile before the IT equipment. This is the last equipment that will be able to control power and deliver power to the IT servers.
It's in the border.
It's the frontier for sure. So if we consider the PDU, you have to have a means to know what the IT equipment is consuming in terms of power, how the IT equipment is behaving. Do I still supply power to units that I don't use anymore, and they still continue consuming power and dollars that I still have to cool them? So how can I identify these servers and remove them? Or if I have a peak in my activity, if I have a big application that consumes a lot of resources, how can I redirect the load from servers that are not needing the power at a certain instant to the critical load of my main business servers? So if you don't have a fully intelligent PDU architecture, you can't really do anything. You will just have a standard mean of controlling that architecture.
Okay. Yes, I really agree with you. And according to that you are speaking, there is a person into the data center which plays a big role, and that's the operator or the administrator, right? And that's the person who's taking the information from the PDU or the rest of the equipment into the installation. And mainly, that person is turning on, turning off, switching the equipment, switching even the circuits. And that person must be 24 hours, 7 days per week. I really believe they don't have life. And I feel like an admirer of them because they are very clever and they are very compromised with their labors. But of course, they need sometimes to do a close. They need to do a switch for their lives. And what happened if that operator or that administrator of the net needs to leave the building, needs to go out for going to the doctor, I don't know, or just doesn't have enough time for switching or for doing a tour equipments one by one? And how can a PDU help that person, that important person, that critical person, rather, into a data center with its management?
Yes, and that's a question. That's a question that a lot of our customers are asking themselves because, as you said, it's a harder and harder job to fulfill today. Operating facilities, because we have less and less teams and skilled technicians available to go on the rack itself and unplug the equipment or reboot servers manually going there in the facility. When you operate facilities that are remote or edge and pop sites, some of our customers have 10,000, 20,000 pop sites with rolling teams to visit them. But if a problem occurs on 100 sites or 50 sites, it's almost impossible to control everything with an actual physical body, a person to go there and look at everything at the same time. This is why we created switch PDUs and controllable architecture and infrastructure remotely. So the goal for that is to have a mean of having a remote hand into the architecture, meaning that you can turn on or off servers remotely by switching on and off outlets, and aggregate all data, meaning that you will be able to control all the servers remotely and sequence their boot up or power cycling them to reinstall the firmware inside them. And you're going to be able to control how much they consume and turn off the power, as we were just mentioning. So the means of controlling that goes with also the ability to identify any error or anything that might go wrong. For example, if you have a rack with 2 PDUs, if you have a level of redundancy with 2 power lines arriving into the rack, if you have selectivity power issue or short circuit caused by a power supply inside the server, and you lose circuit breakers, one power line might fail at some point. You want to make sure that your second power line is not in a risky situation and will be able to take over that load. So if both sides are charged up to 45, 50%, for example, if you have 9 kVA on one side, 9 kVA on the other side, if you lose one side, the other feed can take 18 kVA. If you don't have enough power, then you are at risk of losing the entirety of the rack and also escalating that failure upwards. Upwards, that means that I'm losing a row, I'm losing a corridor, I can even lose an entire room. So the cascading failures are not something that we want to experience as an operator. And it always happens when we sleep, when we're not there, because we have to live, we have to eat. So it's very critical to be able to have a remote hand, and as soon as we have an alert, redirect any uncritical loads and switch off equipments and really control that with an accuracy that you wouldn't have otherwise.
Right. Yes. Look, when you are speaking about the importance of the operation, I think also about the owner of the data center, because that's the person with the money into the pocket, right? And it's not just for the operation, but also in the moment that the data center is in the process of being designed or being built. There are different stages of data centers processes. But how can a PDU additionally contribute to the optimization of costs in the data center?
Yeah, so basically PDUs are a mean of knowing what's happening live in the data center. So with a PDU, you should be able to see how much every device is consuming, because you would deploy intelligent PDUs with outlet level metering. And that's the highest kind of feature set that you can have inside the rack that would give you the ability to see exactly what every server is consuming in terms of power. If you can also identify failing power supplies inside the servers by having a deviation from mean mathematically and setting up alerts, you'll be able to discover which power supply is going to fail, and that can also lead you to predictive intelligence. Always being predictive rather than reactive allows you to save costs and schedule your maintenance, schedule your reboots inside the rack, so you don't have to do it reactively and scramble to fix an issue that might escalate very quickly. So that's the first item, is the day-to-day management of the infrastructure. That's how the PDU will help you by giving you the tools to control remotely what you need and also get the information. Another aspect is the pure power consumption of your data center, because once you know how much you consume, you can act. And acting, what does that mean? You will decide to shut down some parts of the data center. You will decide to grow your footprint, because if you consume too much power, that power transforms into heat. That heat, you have to remove it. That means that you need to have the cooling infrastructure to do so. And if you come to a saturation into a data center, that will cost you even more and more and more money. It's exponential, the amount of money you will have to spend to cool the equipment. Same thing with the life cycle of the equipment. If you don't have the information of how much they consume and how they behave, creating baselines of power consumption, there is a very high risk that you will create a situation where the life cycle will shorten because they are in an environment that is not suitable for servers. Too much humidity, too much heat recirculating through the equipment, a bad power quality, damaging the power supplies, creating issues. So it all revolves around the same sanity of belts and suspenders in terms of power, in terms of architecture, but also then in terms of intelligence to have full control.
Right. Just for finishing, because the time it's taking us. According to your experience, what the main recommendations you would do to a data center administrator or designer or end user or owner at the moment of choosing a PDU?
That depends on the owner, but that question is sometimes overlooked because that depends on who asks us. If you're from the facility side and you're not going to operate, most of the time facilities people will consider efficiency and cost, making the most of the infrastructure that they can make available. When you look into the pure operation and IT side and network management side, as we discussed prior, you need to have the remote hands and the full control. And the smaller your team, the more intelligence you're going to need to operate your infrastructure remotely. So in that case, you're going to need the most intelligence you can get out of the product. And this, we're here to help you design the type of intelligence you're going to need, but also the power configuration. The philosophy that we're pushing to the market is to really place yourself from the IT equipment, not from the power panel, not from the UPS, not from the bus bar. When we design PDUs and when we design the power chain as a whole, we have to start by the IT equipment. And it's not always easy because sometimes we don't know exactly what will be deployed and we have to make choices. So how do we do it? We model a typical application power consumption and typical BOM of units that are going to be deployed. And we architecture the different branches of the PDU accordingly. These branches needs to be either protected by circuit breakers to secure the user, right? And also disaggregate. So if there is a short circuit, it will interrupt the current. And also make sure that if you, as we discussed, lose one side of the redundancy, the second side will be able to take up the load and continue operate the equipment. So designing these branches and that configuration is the expertise of Legrand, providing the right power configuration and then scaling it across all facilities. The more standardized you're going to be, the less complexity you're going to have to deal with. Many generations of units, many brands, many vendors create a lot of complexity, and that's detrimental to the correct functioning of the data center. So on one part, intelligence, on the other part, accurate design and operation of PDUs.
Exactly. Well, time's off. So, Nicola, really, thank you so much for sharing with us this time, for giving us your knowledge and your experience. This is an open invitation for a future talk to you because there are a lot of topics to talk about, but time short.
All right. I appreciate it. Thank you so much, Maria. And we're here to help, so don't hesitate.
Of course, as always, you're always help. Thank you so much. Y gracias a toda la audiencia que ha compartido con nosotros este espacio o que a futuro va a ver el video. De verdad, apreciamos mucho todo lo que han hecho ustedes con nosotros, digamos que toda la fluidez o todo lo que ha venido ocurriendo con esos conversatorios. Los invitamos a que vean los anteriores si no los han visto. Este va a quedar colgado, en plataforma para que a posteriori lo puedan también consultar. Estamos para ayudarlos, estamos para servirles y los esperamos en un próximo Conectados con Legrand.